Did you know you can reverse a string in Python with just 3 characters? Can you guess how? Welcome back to our Python strings journey. Did you know a vast percentage of the data you interact with online every day, from emails and tweets to website content, is text? Mastering string methods isn't just a Python skill. It's essential for processing the digital world around us. Python strings come with a bunch of pre-built tools called methods. Think of them as functions attached to the string itself that perform specific actions on it. We call them using the dot notation, string variable dot method name. My string equals hello Python coders. First, let's quickly revisit slicing with a step, which we didn't cover in part 1. The full slicing syntax is start, stop, step. Step tells Python how many characters to skip. The default step is 1. Slicing with step. Print original my string. Print every second character : 2 my string : 2. Start to end. Step 2. Print every second character from index 1 : 2 my string 1 : 2. From index 1 to end. Step 2. A cool trick: reversing a string using slicing. Print reverse string : :-1 my string : :-1. Start to end, step -1, backwards. That : :-1 is a common Python trick for reversing strings. The len function, not a method but essential for strings. Print f length of the string, len my string. Okay, now on to the methods. We'll start with changing the case of letters. Case changing methods. Print f original my string. Print f.upper my string to upper. Converts all characters to uppercase. Print f.lower my string .lower. Converts all characters to lowercase. Print f capitalize my string capitalize. Capitalizes the first character, rest lowercase. Print f.title my string.title. Capitalizes as the first character of each word. Notice that none of these methods changed the original my string. They returned a new string with the changes, just like we talked about with immutability in part 1. One tiny mistake can crash your whole program, and it's hiding inside the index method. Finding substrings. Text to search equals Python is a powerful programming language. Python is fun. Print f original text to search. .find returns the lowest index where the substring is found, or -1 if not found. Print index of Python using find text to search find Python. Printf index of Java using .find text to search .find Java, not found, returns -1. Index, similar to find, but raises a value error if the substring is not found. Print f index of powerful using index, text to search index, powerful. Potential error substring not found with .index. Print f index of Ruby using Ruby. Uncommenting this will cause a value error. Use .find when you just want to check if something exists and don't want the program to crash if it's not there. Use .index if you expect the substring to be there and it's okay for the program to stop if it isn't. Replacing substrings. Bad sentence equals this is a bad and terrible sentence. Print original bad sentence. Replace old new. Replaces all occurrences of old with new. Good sentence equals bad sentence. Replace bad, good. Replace terrible, great. Print f dot replace good sentence. You can limit the number of replacements. Duplicate words equals hello, hello, hello. Print f original, duplicate words. Dot replace old, new, count replaces count number of occurrences. Single hello equals duplicate words, dot replace hello, h high 1. Print replace single hello. The replace method is incredibly useful for cleaning up text or making substitutions. Removing leading, trailing white space. Messy string, lots of spaces around. Print original, messy string. Use quotes to show the spaces. Print f, strip, messy string, strip. Remove spaces from both ends. Print f l strip, messy string l strip. Remove spaces from the left, leading. Print f r strip, messy string r strip. Remove spaces from the right, trailing. Can also remove specific characters from ends. Dotted string equals hello world. Print f original dotted string. Print f strip dotted string strip. Strip is your best friend when dealing with user input that might have extra spaces. Checking prefixes and suffixes. File name equals document PDF. Print file name, file name. Print f starts with doc, file name starts with doc. Check if string starts with doc. Print ends with .pdf, file name ends with .pdf. Check if string ends with .pdf. URL equals https www.example.com. Print URL, URL. Print f dot starts with URL, starts with HTTP. Print f starts with HTTPS, URL starts with HTTPS. These are great for checking file types, URLs, or other specific patterns at the beginning or end of a string. There are many more string methods. Two important ones you'll see often are split, which breaks a string into a list of words or parts, and join, which does the opposite, combines a list of strings into a single string. We'll cover these more when we talk about lists in the next lesson. We've just covered some of the most common and useful string methods. Practice using them. The best way to learn is by doing. Let's put some of these methods to work in a small project. We'll create a script that takes a sentence from you, the user, and does a few things with it. First, we need to get input from the user. We use the input function for this. Print simple input processor, user sentence equals input, please enter a sentence. Handle potential empty input. If not user sentence, print you didn't enter anything. We could exit or loop. For this simple demo, let's just stop here. Exit. Exits the script. Good practice to check if the user actually typed something. Now let's make sure we process the text in a consistent way, regardless of how the user typed uppercase or lowercase letters. We'll convert the whole sentence to lowercase. Convert to lowercase for easier processing. Processed sentence equals user sentence dot lower. Print f original sentence user sentence. Print f lowercase sentence processed sentence. How long is the sentence? We can find that using the len function. Find the length of the sentence. Sentence length len user sentence or len processed sentence. Length is the same. Printf length of the sentence, sentence length, characters. Next, let's check if a specific word, say Python, is present in the sentence. We can use find or the in operator. Using in is often simpler for just checking presence. Check if a word is present using in operator. Search word equals Python. Check for lowercase python because we lowercase the input. If search word in process sentence, print yes, the word search word is in the sentence. Else, print no, the word search word is not in the sentence. Alternative using .find. If process sentence find search word not equal -1, print yes, the word search word is in the sentence using find. Finally, let's try to replace a word if it appears. Let's say we want to replace any mention of bad with good. Replace a word, example, replace bad with good. Word to replace equals bad. Replacement word equals good. Modified sentence equals processed sentence. Replace word to replace. Replacement squirt word. Print F sentence after replacing word to replace with replacement word modified sentence. Let's put it all together in one script and add some clear output. Great, we've used input, lower, len, the in operator, and .replace to build a simple text processor. This shows how you can combine these tools to work with real-world text data. Time for a challenge to test your understanding, especially of slicing and maybe case sensitivity. A palindrome is a word, phrase, number, or other sequence of characters that reads the same backward as forward, like level or madam. Your challenge is to write Python code that takes a word or phrase and checks if it's a palindrome. Hint: remember that cool slicing trick for reversing a string? Compare the original, maybe after cleaning up spaces or changing case, with its reverse. Want to explore further? Check out the .count method, which tells you how many times a specific substring appears in a string. For more advanced text processing, you might look into the string module or even the powerful world of regular expressions, regex, though that's a bigger topic for later. Wow, you've learned a ton about Python strings. In this video, we mastered essential string methods like changing case, finding and replacing text, stripping spaces, and checking starts ends. We also put these skills to use in our simple user input processor project. Understanding how to work with strings is vital because text data is everywhere in programming. You now have powerful tools to handle it. We've dealt with sequences of characters, strings, but what about handling collections of different types of data, like a list of names, ages, or prices? That's where lists come in. In the next video, we'll explore lists and all the amazing operations you can perform on them. It's another fundamental Python data structure you need to know. Don't forget to check the description below for all the resources. The code snippets from this video, the Palindrome Checker Challenge, suggested extensions, a downloadable summary, and a quiz to test your understanding of string methods and the project. If you found this video helpful, please give it a like and subscribe to the channel so you don't miss the upcoming lesson on lists. Thanks for watching, and I'll see you in the next one.